DevOps. I know most of the technological people around here knows what is DevOps is, right? I believe DevOps is this. We have agile process. DevOps come based on agile, right? We have agile methodology. So what's agile? Agile is actually delivering as soon as possible. That's what agile came with, because we are moving out of STL, the classic waterfall structure, and bringing down the agile software development to make sure the delivery is faster into the customers. And the other one is CI/CD. So these are the two basics I would see where DevOps is lying on. With agile process, with automation coming by CI/CD, we have established that DevOps is properly functioning in an organization, right? What is security in this, right? That's my question. That's my use case today. What is security in this? How can we embed security into this? So I thought of bringing up a use case or more of a story, right? So the first point is, if you talk about the industry, every industry has some software component. Some either way, at any point of the time there is a software component. So that's the start of it. And what happens if you have a software component is that the exploits are increasing. It's not that the software, it's only that software is being, so the hardwares are being attacked. Most of the time the software is being attacked by attackers, maybe threat actors from nation state and every other way. So software is a very important part, and since we have a software in any component or any function in organization everywhere we speak, and the attack points and the software vulnerabilities are increasing day by day. And also the third point, how can we try to implement security in this is by trying to mitigate these software vulnerabilities through processes like security DevOps. We are implementing security into the life cycle of DevOps. So this is my use case. And do you think the question is correct? Security DevOps required or not? Let's see after the session. Right. So these are our normal general life cycles of DevOps. DevOps starts with plan, right? What comes with the DevSecOps is the strategy to shift left. What is shift left strategy? Shift left strategy is that we start from the beginning, from the planning stage, where we design, we give threat intelligence platforms, we implement threat intelligence. We bring in the secure by design concept, where software architectures, source code developers team together in that initial team meetings to bring in the security factor into the design of a software. That's what shift left is actually, moving towards the start of it. Secure by design concept, privacy by design concept. These concepts are also very important because this brings the security requirement or the privacy requirement, so mainly the cyber security point of work in a software to the start of it. So in the plan stage, we do work on threat intelligence. There are different platforms that provide us threat intelligence, and there we do threat modeling and risk assessments. So I know these are words that describes things, but these have underlying concepts on it and underlying tools on it and underlying infrastructure, underlying resources that works on these standards, frameworks that gives this assessment. That's how we try to integrate security into the plan stage. Moving on, the code stage. When the software developer is starting to code, what should he has actually? What should he have? He should have the knowledge of security. He should have the knowledge of developing security into the source code. He should have the knowledge of integrating different tools in the IDEs. Most of the time, the software developers are built on IDEs. The softwares are built on IDEs, and these IDEs helps the software developers to work on the software faster way, that by integrating this in automated manner. So how can we implement security into that? We can integrate these tools for these IDEs and train the software developers to make sure the secure practices are implemented in their source code, right? So this is the aspect of security in our code line, code level, right? Moving to build stage. When we are building the software, what should we focus on? When we are building the software, we will be building almost everything that we can assess as a software in their really the build stage. So, we can implement logging mechanisms, we can implement security managing in the DevOps, the dev cycle, the production release cycles. We can implement software code analysis in software components like SCA scans, software composition analysis, many things. These list down very little of the aspects of security in DevOps, but this gives an idea how the security should be implemented. And mainly the failover strategies. Usually when building a software, we should always have the backup strategies, the failover strategies for software, how to come back to the original state. And I think we know from the software repositories that we are managing that that's the aspect of DevOps to have a better failover strategy. So, that is one part of security in DevOps. Moving towards test. Test is one of the important stages, and nowadays in DevOps cycles, test is included mostly on quality assessments, unit testing, most of the day. But what SecOps suggests is that we need to implement security into these testing strategies. We can bring in these code quality security assessments. We can bring in the static assessments, dynamic assessments, different ways of assessing software. And mainly nowadays we are focused on SBOMs. Many standards frameworks talk about software bill of materials, right? We can implement composition analysis tools to bring in software into that. Bringing the assessments into that, perform attack simulation. Moving forward, we have the release stage in our cycle. The release stage, what does it do? We have, once the software has been released to a stage environment that we can use, the developers can use finally to do a deployment. In the release stage, we can do the compliance assessments, right? We have the focus on identifying the compliance requirements before the software is released to the production. We can make sure the cryptography and security key management is established, because that is one of the most important ones, because we don't want vulnerable cipher suits. We call them cipher suits, where the cryptographic key functions are being released to the production environment. So, cryptography and security key management in the release stage. Deployment, right? In the deployment, what should be focused? Now, DevSecOps is not actually working on software security as a development stage. It works on the deployment stage of the infrastructure. So, we have nowadays we are cloud native environments most of the time organizations have. We have container security, we have Kubernetes orchestration security requirements. Everything should be established at the deploy stage. We have Kubernetes guidelines, we have this orchestration, other OpenShift like OpenShift. We have other open source security orchestration services that works on deploying, managing containers. So, those have some sort of security guidelines that we should be implementing, and at the deploy stage as a DevSecOps practice, we need to make sure these are implemented. The final one, the monitoring stage, right? What is the monitoring stage? Monitoring stage, this come again with threat intelligence. Threat intelligence, there are many open source platforms and there are many commercial software tools available that gives us the threat landscape of a software, or maybe threat landscape was targeting specific industry, that we have these threats in these areas. That gives an insight on the production or the production software we have out there as an organization. And also we can use the SOAR that we discussed, security orchestration, automation and response. We capture the logs, we capture the insights of the software in the operation in the production environment. Then we make the analysis to try to find out, are there any future attacks or maybe future potential of being attacked. So, that is what we focus on in the monitoring stage. So, in the DevOps cycle, all the phases have some sort of security aspect that we should include, that we can bring in. So, that is highlighted by this context. Diving deep into it, I believe security practices bringing into DevOps should work on these three aspects. We should bring in the process aspect, where we talk about the understanding of the developers, the initial setup of security practices that gives us the idea that security should be implemented. That is why the security mindset aspect is there, right. The points. We should bring the PPT, security into the PPT. We should bring security into people, process technology, and the governance practices. Then we should bring the improved decision making from the outcomes, right? From the outcomes of these security practices. So, and while bringing these practices in, that we make sure security has become a culture into the organization rather than just a suggestion, right? So, how we are trying to, what we are trying to establish from practices is that we are going to bring the culture into the organization to implement security. The third point, of course, we need to manage the IAM requirements, we need to manage governance requirements, we need to manage monitoring requirements, the artifact management in a software development process. Yes, so that establishes the practices stage of a software DevSecOps cycle, or actually the software development life cycle. Then comes the automation, one of the main things that we can bring in with CI/CD, right? We have at the current stages in most of the organization, DevOps is with CI/CD, and CI/CD is automated at the most of the phases. There are manual work, of course, but most is automated with tools. How can we implement that in security? Yes, we can implement security tools. There are plethora of security tools that is open source and also commercial that is available that we can implement into CI/CD. So, the automation stage actually brings in the automation of tools to the CI/CD that reduces the stress on developer, or maybe some security person who should be working towards implementing this. The final stage is the compliance stage. What we achieve from this SecOps process is to make sure we do not have vulnerabilities in our system. Once we deploy software into the production, the organization in overall should make sure that there are no vulnerabilities in the system. So, there are different databases like CWEs, we have CVSS scores that gives us a score on the vulnerability matrices if we have any vulnerabilities in the system, right? And the continuous monitoring of applications, that is that, as I spoke earlier, this is regarding the security monitoring with these threat intelligence platforms, SIEM tools and everything, that we achieve the compliance. And finally, important one, in every industry, as I spoke, there are requirements that we need to establish in software development. So, we can achieve that from aligning to the CSMS standard, CSMS framework, where organization has established, or maybe there are regulatory compliances that we need to establish. That is what that can be implemented. For example, type approval Google certifications that we come across mostly in automotive industry, when we are deploying software in the automotive industry related work. So, that is what we achieve from compliance. So, these three areas are the main things that we need to dig deep, or actually understand in deep, that we can implement DevSecOps as a DevOps process. Right. I thought of giving out implement stage in a more descriptive manner. So, in DevOps process, we have this planning, development, building and testing, and production and operation. And how this comes in the DevSecOps process, we need to, as I always spoke, we need to create the DevSecOps culture, where the organization is actually working on the DevSecOps process in every aspect of the software development, not only at the final stage where we do final security testing and then release the product, but every time we design a software, or every time we establish something that we are going to have. If there is a new feature coming up, then we should make sure the DevSecOps process is also integrated into that. Then each person in SDLC codes builds, tests, configures application security infrastructure defensively. What do you mean defensively? Every time when we are deciding on something that we should implement, we should make sure that it has a security aspect approach to it, right? Every architecture should be able to give out at any instance, yeah, these are our security features. These are our security features in this particular release, and these are our security strategy in this particular release. So, that knowledge, that understanding should be there in the software development design phase. these points follows as, so working towards planned requirement in the feature work, as I said earlier, then modeling the threats, working towards designing your software based on threats, and identifying the threat attack scenarios, we call these attack vectors, identifying the different attack vectors that a software could be exploited with, and explaining, building up a structure that we can make sure the security has been implemented into the process. Right. So, moving to the second phase, building and testing. What we can implement in building and testing, of course, we have the CI/CD automated gated testing. With my experience, I know most of the time organizations try to push the gated process into the CI/CD with security, but when the timelines approach, most of the time the gated related to security will be hindered, I would say, would be prevented. Why? Because the organization will be mostly focused on the delivery of the software rather than the security of the software. So, if we have a gated process implemented, which means that there is a specific gate that as a software should bypass or should pass and should have a valid result from the gate that we have implemented in the CI/CD with DevSecOps or security process, that makes sure the software is output to the production environment as a secure product. Number 2 point, it's pre-commit hooks. Now, everyone who is in development software development know what are pre-commit hooks. Before we commit to from the staging phase to another branch that we accept into the final stage, before we commit that source code from the IDE to the staging stages, we have pre-commit hooks where we have this lint tools. There will be more discussion, description on the tools at the later stage, but there are lint tools that we can implement at the IDE stages that we can bring in the building. So, building and testing focuses on basically the developers aspect of implementing security and doing testing on their work structure in the process. Then post commit, after you committing to a certain repository, do we do the scans on it, right? Do we perform different validations? So that's what focus on building and testing. And of course, the CA tools that I spoke about earlier that gives out composition regarding the software, working towards it, and the vulnerability requirements, right? So that gives us how we are going to structure the DevSecOps requirements in the building process, in the building and testing process of an organization in the security perspective. The final one is production and operations, right? How we are going to do the production operation? Still with the tools. We bring in tools that we can give out certain insights on the organization. The word incident triage, what do you mean by incident triage is, if we are focusing on a security incident in an organization, do we have the insights of working towards how this incident happened, what we should take to resolve this, and how we are going to prevent it from in the future happening. So that's what incident triage is. So we should implement tools we bring in tools to the DevSecOps process, at least the DevOps process, that we can monitor and implement incident triage. This is just one example of working towards incidents, but there are many other aspects. Then periodic post-deployment security assessments. We do penetration testing, we do vulnerability assessments. Those are different security processes that we shall implement at the final stage of production. And compliance achievements, different standards, different regulatory requirements that we achieve from implementing. For example, cyber resilience framework, EU recently brought in Cyber Resilience Act. So that gives a way that we should implement software development into security into software development. And the infrastructure security optimization, of course, I spoke about this Kubernetes environments, container security requirements. So we can establish not only the software that we are deploying, but the environment that we are deploying the software is also secure. It has the security requirements in it. No one can tamper into it, no one can change it, because not only software as a product will be vulnerable to an organization, there will be attacks that is focusing on the environment. If there is any public point of access to such environment, will be a good opening point for an attacker to access in it. And finally, the backup and disaster. This is not security, but it's actually a requirement as of availability. Every organization should have a backup and a recovery strategy, and also a disaster recovery strategy, which is focusing on in case if a disaster happens. Disaster does not necessarily mean that is a disaster that happens that from unavailability from a natural event. It could be a nationwide attack that can be happening, right? So what are the strategies that we can implement for a software or maybe the DevOps environment, how to recover from those? That's what we can bring in for security in the production and operation. Now you see how security should be broadened in the DevOps process. Just not that we do a penetration testing at the final stage of a software release, but bringing in this reduces one by one when it comes to the final stage rather than deploy, because most of the time what happens is when we are trying to deploy a software at the final stage and ask a security assessment person assess this product and give them a security view on it, what they will say, there are 300 vulnerabilities in the software. What happens, the software developers will get panicked, how are we going to resolve this, but it's not possible because they have already integrated many libraries to the software. We cannot revoke those libraries, then there will be issues. So having a structure that attends from the planning stage until the last stage of production, this gives us a better scope of security, trying to implement security in a better way. Right. Two important things, threats and risk. I will bring in two incidents that happen, and I think most of the people already know this or know some of this about who is in the tech world, and some may have heard about it. The XC utils backdoor happened very recently, last month. This is it's considered one of more more strategic plan into software chain attacks, where this is how this happened is actually a developer has taken the control of this repository not in a legitimate way, but through a legitimacy. When the real owners, the maintenance has requested someone to take over the control, this person back 2 years back has got the maintain access and has maintained as a legitimate developer to the repository for a long time. Then later it was noted last 3 weeks back that this particular developer is considered to be a nation state actor from China, right, who has planted a bugged software into this repository. Now XC utils is something that we all know that is very used in Linux environments. XC, which we use for compression of tar files. So the attack is focused on tar balls. I mean that's more technical on it. So that the software, the maintainer, the person who has implemented the exploit has brought in this vulnerability and planted it into the software, and this has been found 2-3 weeks back. Still we do not have the knowledge of the understanding how big this has gone into the organizations, but still but this has been already starting patching. So usually when a security issue or threat comes in, there is this body that assigns a CV number. So this CV number actually gives us the threat or the risk on this security or the vulnerability.
Which organization was this?
This security? Yeah, this is this CV that is maintained by OWASP standard that gives this CV number to it, and also the Red Hat Foundation. There are different foundations that assign a CV number. So what CV stand is common vulnerability enumeration, that gives a vulnerability value to the organization or to the particular vulnerability. Why I wanted to bring this is this software supply chain attack. This is one of the software supply chain attacks. Software supply chain attacks can be mitigated can be not can I do not say that it can be resolved from DevSecOps process, but it can be reduced from DevSecOps process. In here what happens is the maintainer has got a legitimate access throughout 2 years, and he has exploited his own access to deploy a vulnerable software, a malicious script into the software that can exploit SSH. That's the internal part of it. But what can the DevSecOps process do? If there is a process that always evaluate to do assessments on the software releases, then there is a possibility that we can identify this before we release it to the production. Fortunately, this has been deployed in beta versions of new Linux versions that came out, not mainly on final versions of Linux like Kali Linux or Ubuntu, but this has been decided to be released in beta versions of next in these different flavors of Unix environments. And these organizations like DB and Ubuntu has identified this and has already applied a patch. So, as I mentioned, if we have a thorough process of security in our DevOps life cycle, then we can make sure these vulnerabilities are not being embedded in the software. If you go through. Number 2 point, the SolarWinds backdoor. This has caused actually to produce one of the major executive orders from US, that SBOM is very important in future production in every organization, even in government software. So, I want to highlight how the software SolarWinds backdoor has impacted. That is why it has cost the company to pay $26 million. It's not easy, because a company who maintains SolarWinds is open source. It came in as an open source network management tool that manages the network in an organization, that gives insight of the organization. And then they have these commercial versions, and this has been deployed in many US organizations, even in government entities. And once this backdoor, which we call as a RAT, which is where we have a remote access Trojan that has been planted inside the SolarWinds, vulnerable software. SolarWinds has this Orion software which manages pushes the updates to the SolarWinds software, the main software, and a team has identified, attack team has identified this vulnerability and has planted what you call a remote access Trojan software part. For understanding, it's a bit of a software that has a planted inside this SolarWinds Orion system that can exploit, gives us remote access to the organization's SolarWinds architecture or SolarWinds deployment. Once you the threat is actually really high, because once you get an access to infrastructure like SolarWinds that manages the organization's network, which means that you have access to every other component of an organization, just not only the infrastructure. Right? Moving forwards, tools and techniques. What can we implement in tools and techniques to this to bring in security into DevOps? The first one is actually I need to give out, I am giving out the technique of threat modeling, which I oftenly spoke about in the last few slides. We have 3 approaches for threat modeling. We have asset-centric approach, we have this attack-centric approach, and we have this application-centric approach as defined by OWASP. OWASP is the major community standard that defines security strategies, requirements in software mainly. In our 3 approaches, there are different methods that we can implement a threat modeling. If let's take for example, and if it's a software attack, if you take the attack-centric approach, we always look into the 4 points of the motive of an attack. What are the means of the attack, the software? What are the entry points for a software? Where can the software be entered, and what exploits can be done? And what are the opportunities that we have? Does this software been available in the public, or has this been in a secured repository? Should we access in that? What are the opportunities that we can get access to the software? And then we finally create a list of threats. There are different other frameworks that we can implement that is called the methodology of threat modeling, like Microsoft Stride. We have a methodology that implements Stride, and there are there is something called DRIDE, which is also some threat modeling methodology that brings in the methodology to implement one of these approaches. So, in threat modeling in software development, we can focus that there are 3 approaches that we can implement to have threat modeling. Is one is asset centric, one is attacker centric, one is application centric. So, implementing one of these approaches, we can make sure the threat modeling has come to a mature level in software development life cycle. Right. I like to bring in different set of tools that can that can be implemented in DevOps process. For us, I'll be starting with threat modeling tools and pre-commit tools. In people who in software development already know what are the pre-commit tools are. So, these lint tools such as SonarLint and threat playbooks like these are actually tools that you can search on Google that we can implement in your organization if there is a plan of implementing DevSecOps process in organization. For example, Microsoft threat modeling tool, and there is this OWASP modeling tool. These modeling tools can be implemented into the organization's DevOps process to make sure the threat modeling has been done. Then comes the infrastructure as coding. So, this is one part of the tooling things. Infrastructure as coding is focused on tools like Helm, Kubernetes that we implement, that we use to deploy containers in these orchestration platforms. Like Terrascan, Checkmarx, KCS. These I was expecting to give some examples in this. So, this that we can implement at different stages of our life cycle, of DevOps life cycle. Then comes this software composition analysis tools, SBOMs, that creates the SBOMs. Cyclone DX formats, which is OWASP open source format to produce SBOMs. Now, organizations are actually looking into these SBOMs, and they require these SBOMs to be published with the software, so that organizations can review this once before they deploy into the production environment. Snyk is a very popular tool. Maybe some has used in their work line to implement this, and a very well known tool is dependency track, which goes close by with a tool of commercial tool called Black Duck, which is one of the other tools that we can implement to bring in software composition analysis. So, these tools comes in every the aspects, different aspects of software development life cycle. In the DevOps life cycle we spoke about, from the plan, build, test, release to monitor. These tools come in different stages, so we can bring in. Right. Then we have the static application security SaaS tools. SaaS tools like SonarCube, SemGrep. These are 2 commonly used tools that I have used. These tools are very good in producing code reviews, right? Doing code reviews to identify security vulnerabilities in it before we deploy a code, before actually in the build stage, before we do a release. So, these tools like focusing on Java applications, we have find security bugs. These different tools helps us to implement security as in the static phase. A static phase is where we deploy before we deploy it into the production. Then comes the interactive security testing, dynamic security testing tools, container security testing, and secret management. These are also a set of tools that are very important in implementing security testing at different stages. So, if you take about interactive security application testing, is that once application is running at production level, there are tools that we can monitor the application, that we can send in attack request to the application and see whether the application is responding in a different way, whether we can exploit the application. Those sort of application security tools are called interactive application security testing. Then we have this dynamic application security testing tools like Web, SAP Proxy, Nuclei. These are open source, and also there are commercial versions of these tools. These tools help us to do penetration testing activities, right, in a software application, or maybe to do vulnerability assessments in the software softwares that is in the production. So, when the time that we implement dynamic application security testing is that the time that we have already developed the software and is about to release before we actually release it into a production environment. Then there are tools that we can use in containers that do container configuration scans, whether the containers has write access, can the containers have lateral movement. We call it lateral movement in security, is that once we get access to one container, can we access other containers in the same segments without getting authorization. So those sort of implementations, testing can be done on container security tools or scanning container. These are actually a little, very little bit of tools, but there are many other tools that can be implemented based on the different environment that you are using in implementation. Then there are tools that works on secret management. We have this code secrets. We have secrets that we implement. Sometimes we implement hard code in the software that should not be leaked outside. So these tools helps us to identify whether there are any secret codes that we have implemented hard coded in the organization in the software that will make an attacker easy to identify these security codes. So security management tools like Git leaks and truffle hogs, which I have used, are very easy to implement and identify, do the scans on source code to identify security leaks. Then the other tools like container platform, scanning tools like kubescape, kubeaudit. These focus on the Kubernetes orchestration platforms that do audits, try to implement a security threat scanning on these platforms. Then we have these playgrounds. What are these playgrounds? Is for a person who is trying to learn on DevSecOps, it's easy. These playgrounds allow us to run these different tools in the environment and try to learn on it, right? So this gives a better idea. For example, as a developer, if you want to practice on the security aspect of it, you can use these tools, these playgrounds that allow us to deploy different applications and try the security applications. Then we have this orchestration and reporting platforms. These are actually that gives a dashboard sort of a view on the security issues. For example, Defect Dojo is a very common open source tool that helps us to input all the information that we do scans from different other tools to identify the security or give a dashboard view on the security. What are the security threats, what are the points, what are the exploits and all that. Then we have platforms called chaos engineering. These platforms really help us to implement chaos into the organization. What do you mean by chaos? Is that we try to push with all the security attacks that we can do, right? So this is sort of these sort of platforms that bring in different attacks into the environment and try to see that environment is going to break down. Actually, those are the chaos engineering platforms we have. And then the cloud platform specific ones, the cloud native ones like Azure Insights, AWS compliance tools. We have Microsoft Defender that helps us, and we have then Microsoft Entra ID that manages the IAM profiles of these deployments, and different other platforms that helps in the cloud if you are using depending on the GCP, Azure or AWS. Right. Moving for the last parts, the laws and regulations. What are the laws and regulations that is available that helps us to make sure that the security in DevOps process is required? Starting with the most common industry in Gothenburg, automotive. We know that these standards specifically defined, the standards is regulations specifically define that software composition analysis, the software related security should be established. And then we have this ISO 21432 that defines the software related security requirements, so information security requirements in infotainment systems and embedded systems. And then we have this R155, R156, different other regulatory requirements that defines them. These three are one of the most common automotive industry regulations or standards or frameworks that helps us or gives us that the security requirements in software development should be established. Then if you talk about healthcare, we have HIPAA. We call it HIPAA, which defines the healthcare related software requirements, software security requirements that should be established. Then we have related to financial, retail and economies. We have e-commerce, we have PCI DSS standards that defines what software practices or security practices should be implemented in managing our credit cards, right? How do you going to store the secrets? How are you going to pass the secrets when you are doing a transaction? And how are we going to implement the software development lifecycle related to financial data handling? Then the other roles like energy sector roles, regulations and laws. For example, a recent one is this network code on cybersecurity for electric sector, which came up in EU. So this was bringing into the EU law as a requirement that we should establish security in software development in energy sector products. And then we have this 62433, which is a very common standard that defines security requirements in energy sector, or maybe that's focused mostly on industrial systems, that has the SCADA level industrial systems that bring security requirements into the energy sector. And there are many others like NIS2 directive, which is focused on Europe requirements, and which are other orders like US and other related regions security requirements. For example, the EU Cyber Resilience Act, which came in about 2-3 months back last year, and the NIS2 directive that is more focused on EU related countries, that cyber security aspects should be implemented in every order of software development, not only software development, but in all other IT related aspects of an organization. Right. Finally, the last one. What can we do to be a SecOps guy? I wanted to highlight these few certifications, maybe the reports that we can understand, that we can learn through, or maybe blogs that we can read through. Anyone who is focused on understanding or getting to know the information security aspects of software development, or security requirements, mainly the DevSecOps requirements, someone can follow these certifications. Someone can be achieving these certifications that gives a good knowledge or good understanding on the security requirements to implement them. And there are several blocks that gives us the process of implementing these tools in the software development environment. And the reports like in the GitHub reports like DevSecOps list down many tools that we can implement in the process of DevSecOps to our DevOps process. Yep. So that closes my talk on the DevSecOps process. I hope my use case is established whether we need to have security in our DevOps process. I believe it's yes. What is your intake? Perfect. Thank you so much. For QA.
Any questions? I do have one.
Yep.
Yeah, it's going to be an easy one.
Sure.
On the DevOps life cycle, when you try to make it DevSecOps, where would you start by working in that? Because if you tackle everything at the same time, it's going to be like 20 people working to fix that, right?
Yeah.
So where would you start on that SDLC to start including the security in there?
Yeah, that's the first main point. We should start in the plan stage. The plan stage actually brings in this threat modeling requirements, decisions in security architecture. How are we going to, let's say we are working towards a feature in a software. The security architects and the developers get together in a meeting that we discuss this feature should be implemented, and as a security person, what should be taken into this, that what are the security requirements in that. So for the question, where we should start is actually in the planning stage, the designing stage, where we design a feature. We should implement the security aspect. Let's say the architect asks, okay, what security aspects that should be bring into here? A security personnel who is expertise on this area should say that, okay, we have these standards like OWASP, we have NIST standards. These standards bring in these security controls in a feature like this. Then we should implement these controls when we are developing the feature. That is the first stage where organizations should step in security.
One thing that I see, that I saw happening is the company never cared about security, and then the first breach happened.
Yeah.
Right. It happened in one company that I was working with, and after that they hired like 5 security guys, and they said like, no, don't focus on the planning,
Yeah.
focus on production. So those poor guys, they just started like, oh, let's make all the hardening possible.
Yeah.
But it didn't fix the whole thing because they started backwards.
Yeah.
They started for the last
Exactly.
stage.
Yes.
So, yeah.
That's what my output is on this presentation, also the tech talk also. We should never let security be at the last stage. Once the product is out there in the development, suddenly an attack happens, then all the security guys try to see what the issue is. And all the production has stopped then, and now the focus is to try to fix the bug in the production side. So that should never happen. It should come from the plan state actually. So what happens in most organizations is that once we come to the final stage of security assessment, there are many bugs, as I said, like it's not only 1 or 2, it's like 300 bugs. If you run a scanning test on a production, on a software, there will be like 300 malfunctions or maybe 300 vulnerabilities. Then when we go back with the developers, go to the developers saying that there are 300 vulnerabilities, they are high risk, they are critical, this can be exploited the day that we release the software. They say, no, we can't get rid of this because we have already implemented throughout the whole process. We have already included all the libraries. Some libraries, there may be vulnerabilities like that has happened for about 2-3 years, never attempted by the developers to fix them. But our organization has attempted to bring that library in and develop the software. Once that is done, the feature is there, but the vulnerability is open. So working towards the last is never the way of attempting security. That's what my topic is also like, should be the mindset that we establish rather than working at the last point.
Thank you.
Yep. Thank you. Yeah, sure.
You said about that in IDE, so we should have the security. So if
Yes.
you have a Visual Studio or something, like
Exactly.
that, how you will think to be security will be implemented in IDE, and how you should.
Yeah, there are the most like for tools like SaaS tools that I explained, security static application security tools. There are plugins that we can inbuild to the, or we can pull into the IDEs. For example, IntelliJ, something like Visual Studio Code. They publish their own plugins that integrates with these security tools. So when the software developer is actually building on the software and then trying to make a compilation in the software from the IDE, then these scans automatically run and then give an output that this particular part has a vulnerability. Yeah, there are many tools that helps us on that area. There are many commercial ones and there are very open source ones also that we can integrate into the IDEs. Yeah.
Okay, great. This is to show our gratitude for
Thank you.
preparing and hosting
Thank you
this
so much.
presentation.
Yep.
Very learningful, and it was definitely more than my password change. So I think we're all glad for that.
Yeah, good.
Great, thank you so much.
Thank you so much, guys. Thank you for attending. Bye.